Alright, so here's the Unit 3 review for the Unit 3 packet. I'm going to work on some selected random questions here that I just circled, and hopefully I'll have enough time to cover all the questions I selected here for you. So let's go ahead and work here. Let me get some scratch paper. Put it right here by me. Alright, so I'm going to skip the few first questions here. I'll come back to it. I want to get to I had a student that said, Ms. Myers, you always start with the easier ones on your videos and you never get to the most difficult ones. So I will come back if I have time, but I want to go to the factoring and finding zeros, because that is what you guys have requested, and I will help you with those. So if we have time, we'll definitely come back to the first ones, okay? So let's start with number 9 here, and let me zoom in a little bit more. Okay, so number 9 says, first of all, write each function in completely factored form. So we need to factor it completely. And then we find all the roots, real and imaginary if there's any. And then we need to mention multiplicity. And after that, we're going to find how many x-intercepts does the function have. Okay, so hopefully I'll remember to do all the steps here. Alright, so we have over here 4x cubed plus 20x squared minus 9x minus 45. The first thing, my rule of factoring, is just my own rule of factoring. I always look for the GCF at the beginning of every problem. So over here I have f of x equals 4x cubed plus 20x squared minus 9x minus 45. I have 4 terms, but I'm going to look for GCF before I even couple them 2 by 2s. So 4 and 20 looks good. They can both be divisible by 4. They both have x squares to be divided by, but 9 does not divide by 4, and definitely not 45. So it looks like I have some things that can be divisible here, but not here. These last 2 terms can be divisible by 9, but not 4 and 20. So I looked for a GCF, and I don't have one for all 4 terms. I have 4 terms. I'm going to couple them 2 by 2s, because that's what we do when I have 4 terms. Okay, so I looked for the GCF. Now let's do 2 by 2 factoring. Between these 2 terms right here, we need to look what they both have in common, the greatest common factor. I can divide both of them by 4, and I can also divide both of them by x squared. So 4x squared will be our GCF for the first 2 terms. If I divide 4x cubed by 4x squared, we get an x, okay? And if I divide 20x squared by 4x squared, we get a 5, okay? And if you want to double check, just do in your mind a foiling. If I FOIL 4x squared times x, I get 4x cubed, and 4 times 5 is 20x squared, and there we go, okay? So I know this is correct. We got to carefully make sure that an x plus 5 appears here again. To save me the trouble of having negatives, I want to look for a positive 5. For me to get a positive 5 out of this 45, I would divide by a negative 9, because I know a negative divided by a negative will give me a positive. So I know I can divide both of these by a negative 9. So I'm going to factor out a negative 9, and if I divide negative 9x by a negative 9, we get an x. And a negative 45 by a negative 9 division gives me a positive 5. So there you go. My goal was to make this binomial be common in both of these factors, okay? Then again, I couple them 2 by 2s, the first 2 factors and the last 2 factors. And I'm going to factor what is common, which is what I created. Both of them have the binomial x plus 5 to be factored out, okay? So if I take out the x plus 5, take out is an abuse in mathematics, abuse word, but if I divide this by x plus 5, the quantity of x plus 5, we get a 4x squared. And if I divide this 2 factors by x plus 5, the quantity of x plus 5, we get a 9x as a result, okay? So there we go. What was a 4 separate terms factors out to just be a quantity of x plus 5 times 4x squared minus 9. I always tell my students, first, look for a GCF, okay, that was my notes, and then second, look for difference of 2 squares, okay? That's the thing I write on the board for you guys to remember. Always look for a GCF. GCF, and then look for difference of squares. All right, so now that I got here, I see x plus 5 is a prime. It's a binomial. It's simple. But 4x squared minus 9 is a difference of two squared values. Okay, I know that this is 2, and this is x being squared. And I know that 9 is just a 3 being squared. So I have difference of two squared values. So I'm going to continue factoring. X plus 5 is already as simple as it can be. But this difference of squares is going to become 2x minus 3, my first root and a second root, and 2x plus 3. Now I know I am completely factored, and that's the answer for this part right here. So let me write it over here. Part A was factored completely. We got x plus 5 times 2x minus 3 times 2x plus 3. So that was part A. And then they ask, find all the roots. So find all the x value, x intercepts. Okay, find all the roots of this function. So I know if I solve every single one of these factors equal to 0, I'm not going to show the work, but all I'm doing is setting x plus 5 equal to 0, 2x minus 3 equal to 0, and 2x plus 3 equal to 0. I will find that the x-intercepts, or our roots, are a negative 5, because I set that equal to 0. Negative 2x minus 3, I would add 3 and then divide it by 2, so I would have a 3/2. And then 2x plus 3, I would subtract 3 and then divide it by 2, so I would have negative 3/2. So those are my roots, and they're all real numbers. And their multiplicity is negative 5 only happens once, so multiplicity 1. Multiplicity 1. There's no room to write all that here. And so is the same multiplicity for 3/2 and for negative 3/2. Okay, so it's the same multiplicity for all three of them. And then says, how many x-intercepts does the function have? Well, I have 3 roots. It will touch the x-axis 3 times at 3 distinct places, only once. It will cross a negative 5, it will cross at 3/2, and it will cross a negative 3/2. So I have 3 distinct x-intercepts, okay? So roots and my x-intercepts are already here, okay, with multiplicity of 1 for all 3 of them, okay? So that is how you're going to be solving this kind of problem. You're looking for roots and x-intercepts and how many times you're going to be either crossing or being tangent to it. All right, let's do number 11, which is a cubic factoring. All right, so let's see what we got here. It's asking us to factor completely and then find the roots and how many x-intercepts. Okay, so number 11 does we have y equals 128x to the 4th plus 2x. All right, let me move my paper a little higher here, and let's work on it. All right, so first and foremost, we look for GCF, okay? So I scan it, and I see 128 is an even number, is definitely divisible by 2, and they both can be divisible by x as well. So I'm going to write 2x as my GCF, and let's see what we have left over. 128 divided by 2 is 64. X to the 4th divided by x is x cubed. And 2x divided by 2x gives us a positive 1. So now I have my GCF factored out. Let me write y equals. And now I have my cube factoring. For my cube factoring, I like to go find the 2 roots that I'm going to be using. Just like difference of squares, we find the 2 roots. If I take the cube root of 64x cubed, the cube root of 64 is 4. 4 times 4 times 4 is 64. And the cube root of x cubed is just x. The second root is the cube root of 1. Well, that's just 1 times 1 times 1. So there we go. I have my root 1, which is 4x, and my root 2, my second root, which is 1. So let me continue factoring this. Don't forget the GCF. And my cube root now becomes this small prime binomial and this trinomial. Let me take care of the signs first. It's going to be the same as the original cube, opposite as the original cube, and then at the end is always positive, okay? All right, so my first root is 4x, my second root is 1. So 4x plus 1 is my little binomial. Then my very first term of the trinomial is my first root squared. So 4x times 4x, which is 16x squared. Now, a lot of the students will make a mistake of forgetting to square the 4. I need you to understand that 4x squared is 4x times 4x, okay? So it gives us 16x squared. That's what I have here. Then the middle term is the first root times the second root. So 4x times 1 is just 4x. And then the last term of my trinomial is just the last root squared. And 1 squared is just 1. So there you go. I have my cube factored completely. Very carefully. Find your roots and follow the pattern of the factoring. Okay? So I factored completely, and that's what they asked here. They said factor completely. That's part A. So let me write here, this is part A, to factor completely. Part B is they ask us to find the roots. To find the roots, I'm going to write here roots. I'm going to set every single one of my factors, including my GCF, every single one of them, equal to 0. Okay? So 2x equals 0, 4x plus 1 equals 0, and my 16x squared minus 4x plus 1 equals 0. And you will get credit on the test for showing your steps that you understand how you're getting all this roots. If I divide both sides by 2, we get that x equals 0. So that is going to be one of my x-intercepts. Right now, 0 is my root. I know it's going to be a root on the x-axis, is going to touch the x-axis. If I subtract 1 on both sides, I get 4x equals negative 1. But then I have to divide it by 4 on both sides. We get x equals negative 1/4. So I will be touching, on the x-axis, my function will be touching 0, but also negative 1/4. Okay? Now here, I told you this in class during our notes. This is a prime trinomial. It is only solvable by the quadratic formula. It's not factorable anymore. So I'm going to use the quadratic formula. Let me identify A is 16, is always the leading coefficient of the x squared. B is my negative 4, and C is my positive 1. And I'm going to carefully, to the best I can here without making a mistake, plug it into my quadratic formula. I want to give you 1 point just for plugging in the quadratic formula correctly. Negative B is going to be the opposite. Negative times negative 4 is going to be a 4. Plus or minus the square root of B squared. Negative 4 times negative 4 is 16. Minus 4 times A, which is 16, times 1, which is C. 4 times A times C. All over 2 times A, 2 times 16. So I want to give you 1 point on the test just for setting it up carefully like this. And then students tend to make a few mistakes from here to the end of the simplification. Hopefully you'll be very careful here. So x equals 4 plus or minus 4 times 16 is 64. So I have 64 times 1. So I have 16 minus 64 and all over 32. Okay? Then we continue simplifying it. If I have room here, we're going to get 4 plus or minus the square root of negative 48, because that's 16 minus 64, all over 32. And I ran out of room here. Let me grab another piece of paper. Okay, all over 32. There we go. It's a long work here, okay? A lot of details. All right. So x equals 4 plus or minus negative 48 is divisible by 3. So you notice that all of the cubic factoring, if you look inside of the radical, that number, it is divisible by 3. So look for that division. I'm going to rewrite negative 48 as negative 1 times 16 times 3. That if you multiply in your calculator, you will see that it is still a negative 48. Okay? All that divisible by 32. It was my 2 times 16. Now I can start taking all of these things, the square root of all of these things. So I have 4 plus or minus, the square root of negative 1 is I, the square root of 16 is 4, so 4i, and the root 3 stays inside, all over 32. So if you pay attention to all the examples we did in class, they all end up with a root 3 inside. It's a characteristic only for the cubic factoring, okay? Now I can see that I can simplify this, and that is the last step you need to do to finish this simplification. 4 is divisible by 4, 4 is divisible by 4, and 32 is divisible by 4. So we get 1 plus or minus I root 3 all over 8, okay? If you want to simplify it further, you can separate and say this is 1/8 plus or minus I root 3 over 8, okay? So, and that is your answer. As you can see, I took lots of steps here one by one to show you how to do this. I would not, I mean, if I was doing it by myself, I would not show so many steps. I could go from 1 to, here and finish it. But I like you to see how I plugged it in, and I worked through it slowly until I got simplified. Sometimes the more work you show, the less chance of making a mistake because you're doing it carefully. So for part B, we found our 4 roots. This top 2 over here, I'm going to combine these 2 papers together. The first one is a real number. Okay, so I have a real number. I also have another real root right here. And this last 2 over here are imaginary. So we have 2 real roots and 2 imaginaries. Okay, I want you to see 2 because it's 1/8 plus I root 3 over 8 and 1/8 minus I root 3 over 8. So there's two answers here. Okay, so that's what they ask us, is to factor completely, find the roots, and then they ask us for how many x-intercepts, right? Let me see what they ask here again. Find the roots and their multiplicity. Well, they're all multiplicity of 1 because x equals 0 only happened once, and also x equals 1/4 only happened once, and this one only happened once. So all multiplicity of 1. So multiplicity of 1, multiplicity 1, and also multiplicity of 1. Okay, so they all have multiplicity. They're not tangent, they're not bouncing, they're crossing the x. These 2 are crossing the x-axis because they're real solution. The imaginary does not cross the x-axis. Crosses somewhere in the plane, but definitely not in the x-axis because they're imaginary solutions. And then how many x-intercepts? I just answered. These 2 are your x-intercepts. Okay, so part C is asking x-intercepts. There's only 2 x-intercepts, which is x equals 0 and 1/4. This over here is not an x-intercept, it's an imaginary solution somewhere else in the x and y plane. Okay? So cubic always requires a lot of work, as you can see here on my paper, a lot of detailed work. Okay? And I don't have room to write it here on the worksheet. I'll let you do that on your own time. All right, let's move on to some other questions here, which is, let's do some synthetic division. The majority of my students are working on synthetic division, majority of them. So I'm going to stick with synthetic division. If you like long division, you can double check my work by long division. All this is asking is, g of x is this polynomial right here, and they're saying if one of the roots is 5. Is 5 one of the roots? Well, let's find out by synthetic division. So here's how my synthetic division works. They gave me the root, not the factor. The factor of this would be x minus 5. That would be the factor. So the root is 5. Okay? It's different than here. They gave us the factor, and we have to use the root, and the root here would be negative 3. Okay? If I set this equal to 0 and solve for x, x would be negative 3. So that's the root here. Here they gave us the root already, and I'm showing what the factor would be. Okay, so let's go ahead and do synthetic division so we can see that if this polynomial is divisible by 5. So here we go. I grab my 5 and I set my little synthetic division box. I'm going to make sure that I have all the powers, because all powers have to exist. So my highest is cubed, so I better have a squared, I better have a square x, and I better have a constant. All the powers must be in standard form. The leading coefficient of x cubed is a 2. The leading coefficient of x squared is a positive 3. Then I have a negative 89. Then I have a positive 120 as my constant. Inside of the synthetic, we add. Outside, we multiply. So we always get to drop the first value, the first leading coefficient. And then we're going to multiply. Outside, we multiply. Inside, we add values. 5 times 2 is 10. And inside 3 plus 10 is 13. And 5 times 13 is 65. So we add 65 here. And 89 minus 65, we get 24. So I have a negative 24 right here. 5 times negative 24 is negative 120. So there we go. I got a 0. I got a 0 as my answer. So yes, I would say yes. 5 is a root, yes. And here's the quotient, okay? Here's the answer for it if they ask me. I started with the cubed. I ended with the square. So this is going to become the coefficient of x squared. That was squared. Now this becomes the coefficient of x. And that was my x, so this becomes my constant. If you were asking for the quotient of this division, it would be 2x squared plus 13x minus 24. That would be the quotient of this division. They didn't ask for that, but I'm just showing you that is what these numbers down here represent, okay? So yes, 5 is a root of this polynomial because we got a 0. It divided evenly, okay? All right, now they're doing another one here, and they're saying, is x plus 3 a factor of g? So they gave me a factor, not a root. So I'm going to find the root. I set x plus 3 equal to 0 and solve for x. We got the root is negative 3. So let's do it one more time. Negative 3 is my outside value. I'm going to make sure that I have all the powers lined up. The highest is a cubed, then I have a squared, then I have an x, and then I have a constant. So I do have all the powers lined up, okay? And let me find the leading coefficient, the coefficients for every one of these variables. For x cubed, we have a 1. Squared, we have a 7. For the x, we have a 34. And the constant is 66. We always get to drop the first value. Inside, we add. Outside, we multiply. Well, here we go. The first one. Negative 3 times 1 is negative 3. 7 plus negative 3 is a 4. Negative 3 times a 4 is negative 12. And 34 minus 12 is 22, positive 22. Negative 3 times 22 is negative 66. Positive 66 minus 66 is 0. And there you go. We got an even division again. This number 1 is going to be the leading coefficient of x squared because it drops in powers. X squared drops to an x, and from the x drops to a constant. So again, the quotient, which is the answer from our division, is x squared plus 4x plus 22. They're not asking us for this. I'm just showing you in case you need to factor further. So it does divide it evenly. Here's the answer for our division. So yes, x plus 3 is a factor. And you can write, here's the quotient. Quotient, which is the answer, is x squared plus 4x plus 22. Okay? So we know it is. If I had a remainder of 3, of 4, of anything, then that would not be a factor, okay? Because if you divide a number by another value and you get a remainder, then that is not evenly divisible. It's not one of the factors. All right? Okay, so let's do another one. It says, sketch the graph for each of the following. Okay, we have a few questions here. We want to sketch the graph and then label the x and y intercepts. So it's not just a rough sketch, it's a precise sketch because I need to know the x's and the y's. Okay, so let's go ahead and do this one really quick. look for GCF first. I can see that all of them have an x to give to me. Let me go ahead and write it right here so I have more room. Y equals x cubed minus x squared minus 2x. If I divide all of them by an x, let's see what we have left over. Divide this by an x, we get x squared. Divide this by an x, we get a negative x. Divide this by x, we get a negative 2. All right? Let's continue factoring it. Always look for a GCF first, okay? You can never fail if you always look for a GCF first. Then y equals x. Let's find the binomials. The two values that multiply that gives me x squared is an x, so they go here. Two numbers that multiply that gives me negative 2, but ends up with a negative 1. How about negative 2 times a positive 1? That is a negative 2, but when I add, gives me a negative 1. So that is the completely factored form, okay? And I think I have room to write that here. Y equals x times x minus a 2 and x plus a 1. For the x-intercepts, if I set each of these equal to 0, I'm going to get x equals 0. A lot of the students forget to set the GCF equal to 0. Then if I set this equal to 0, I get a positive 2. And if I set this equal to 0, I get a negative 1. So those are my x-intercepts, a 0, a 2, and a negative 1. Since x is to the first power here, only happened once, this is going to cross. The 2 is also going to cross, and the negative 1 is also going to cross. So I'm going to cross at 3 places. A positive 2, a negative 1, and a 0. I'm going to cross at 3 places in my little tiny graph over here. Because my leading coefficient is 1, it's a cubic with leading coefficient of 1, I am a positive leading coefficient, I am increasing. So I'm going to start at negative infinity, cross here, and cross here. So 3 crosses, a negative 1, a 0, and a 2, and I finish my graph, okay? They did ask for the y-intercept. Just from graphing, I can see that my y-intercept is 0, 0. Okay? If you want to plug in 0 for all the x's here, you're also going to get 0 for y. I like to graph it, and then sometimes it just happened to be a 0 already. Okay, it looks like the bell is going to ring right now. I'm not sure I have time to keep on going, but I will keep on going until the bell rings. Number 20 looks really scary, really, really scary, but all it is I have 2 trinomials that needs to be factored out. So there we go. Let me just get you started. If I factor this out and this out as 2 binomials, okay, you would have a total of 4 binomials for this right here. So g of x equals. Think of 2 numbers that multiply that gives you negative 3, but when you add gives you a positive 2. So x and x is for my x squared. How about positive 3 and negative 1? So plus 3 and negative 1. So when I multiply, it gives me negative 3, but when I add them, it gives me positive 2. So that is how you're going to factor that trinomial. Now focus on this second trinomial over here. The 2 x's, if I multiply, it gives me my x squared. But 2 numbers that multiply, that gives me negative 18. So 3 times 6. But I need a negative 3, so I would do a negative 6 and a positive 3. That multiplied, 3 times negative 6 is negative 18, but when I add, gives me negative 3. And you play with signs until you make sure that you get it correctly. If I had gotten this wrong, then I would just switch their signs and play with it again. So this was really ugly to start with, but if you really think about it, it was just factoring 2 trinomials separately. Now you're going to set each of these factors equal to 0, every single one of them, don't forget. Notice that x plus 3 happened twice. I can actually rewrite this function as g of x equals x plus 3 squared because it happened twice. And then I have my x minus 1 and my x minus 6. So I'm pretty sure you can go ahead and finish all these. Find the multiplicity. You have a squared here, so it's going to bounce or be tangent. This one is just a 1, x equals 1, so it's going to cross. And x equals 6 is also going to cross. And I'm pretty sure you can finish graphing this, okay? As you can see, number 21 is going to be very similar. You're going to factor this this trinomial and then factor this other trinomial. Okay, it will be very similar to number 20. All right, and then we have write an equation right here and write the equation. In the an equation, y equals a times x minus whatever the first root is, x minus whatever the second root is. I don't know how many of these we'll have, but based on what we see here, we have a crossing at -3, we have a crossing at 0, and we have a crossing at 4. Those will be our roots. They are our x-intercepts. We don't have to solve for a because it's asking for an equation. Okay? So this is going to be y equals a, x minus, my very first root is a -3, so I'm going to write here as +3. And then x minus, let's find our next root, is a 0, so here we go. And x minus, my last root is a 4, so let me just write the number 4 there. Okay? Now you can definitely clean up because I don't need to write x minus 0, I can just write an x. And I like to bring it to the front. So it's going to be y equals a, it's my leading coefficient that I don't need to solve for it, times x, which is this guy right here, x plus times x plus 3, and times x minus 4. Now a is a positive number. How do I know that? Because of the end behavior of my function. It is from -infinity to +infinity. So I am increasing. So I can mention that a is greater than 0. Okay? I like you to make sure that you mention something about a, so we know that this is an equation, a is greater than 0. There we go. In this other case over here, we are going to solve for the equation. It's very, very similar, the first steps, like the an equation, but you have this extra piece of information right here, which is 0,3. We're going to use this 0,3 to solve for the equation. Okay, for the a, which makes the equation. So y equals a, x minus, my very first root is a -1, and then I have a bounce at 1, and then I cross at 2. So I'm going to let you finish this problem because I completely ran out of time, and solve for the a value. Okay? And unfortunately, I only did about 5 to 6 questions. There's not a whole lot of time. I wanted to continue factoring some problems here. Find all the zeros for each of this function, how many x and y intercept. So we have a quartic. So remember, it works and behaves very similar to factoring quadratics. We have an x squared times an x squared here, and start thinking of all the factors of -20. Immediately I think of 4 times 5, but I don't know if that's going to work. Okay, it could be 2 times 10, and then we just have to play with those values. All right, let's see what we got here. X squared and x squared are the two factors. Somehow I need to make a positive 1x squared appear. So why don't we make a -4 times 5? That's -20. So how about we try to play with these values right here. If it doesn't work, we'll switch it again. Okay, so how about +5 here and -4 here. Let's play with it. If I multiply 5 times x squared, we get 5x squared. And -4 times x squared is -4x squared. If you add these two values, you do get a positive x squared. And I have red pen, so I'm not going to scribble all over, but if you check it, it does work. Since I always tell my students, first, look for the GCF. Second, look for difference of squares. I always look for the squares. I'm always looking for them because I know in quartics and all this kind of factoring, they pop up all the time. So x squared plus 5 is not a difference of squares, but x squared minus 4 is definitely a difference of squares. So x squared plus 5, and then here's x minus 2 and x plus 2. Now it's asking us, find all the zeros, all the roots for each of this function. You're going to set every single one of these equal to 0, okay? You will get imaginary solutions. It could happen, imaginary solutions. I can see it happening right here, okay? That you're going to get an imaginary solution because you're going to be subtracting 5 and then taking the square root. So And then you're also going to set this 2 equal to 0 and solve for the roots. All right. So unfortunately, I abused all my time here over the break time. Keep on working on this. Here you have 4 terms. Look for a GCF first, and then start factoring. Okay. And I almost cover all of the things. I want someone to please remind me if you have any questions to work on this question right here. It's super important. You will definitely see this type of shifting transformation on the test. All right. Good luck. We'll have a good review on all this again in class.